All right, guys, how you doing? This is Coach Scott, and well, let's just talk about. This is more like a review video on how to do stoichiometry with the BCA method, right? The BCA method. Now, stoichiometry, of course, as we talked about in the past, can be pretty difficult, and a lot of students have a hard time understanding the concepts. The BCA table sort of lets you. Helps you understand what's going on. Of course, BCA stands for before, change, and after. So the first step in doing the BCA method always is to, one, have a balanced reaction. And even if it looks, it's got some coefficients there, I'd always double check just to make sure that it is balanced. Our second is whenever we do the table, we're always going to be in moles. Always in moles. All right. So we're always in moles. So let's throw a balanced reaction out there and we'll fool with it a little bit. So let's see. Let's look at one of these from a little study guide. So I've got 8 moles of NH3. That's ammonia gas. And if I add and react it with 6 moles of nitrous dioxide or nitrogen dioxide, NO2 gas, it will yield 7 moles of nitrogen gas and 12 moles of water. 12 moles of H2O. Water vapor is a gas also. Okay, so if I do this right, I'm going to, one, to understand what's going on, I've got to draw my table. So let's go BCA. And I like drawing little lines because it lets me understand, helps me with my ADHD understand what's going on. So the problem that could be given, or you can throw in whatever we wanted, let's say we have, I don't know, 10 moles of ammonia. So for every 10 moles of ammonia, okay, how many moles of nitrogen gas will be produced? Okay, so if we work the table out, we can answer anything about this reaction that we may want. So let's say for every 10 moles, let's fill it out. And that's a reactant, ammonia. It's going to react with, for every 8 moles of ammonia, we need 6 moles of nitrogen dioxide. Okay, cool. So we know that 6 is less than 8. So I'm going to multiply this number, 10, by a ratio either 6/8 or 8/6 that will give me a smaller number than 10. So of course I'm going to multiply that by 6/8. So 10 times 6 divided by 8 will give me 7.5. So for every 10 moles, 7.5 moles of nitrogen dioxide is needed. Now these are products, so of course before we start the reaction, there's zero products there. We just have the reactants. Now, the change, this is what's going to be gone. Now we know that for these 10 moles, they're totally going to react, and these 7.5 moles are totally going to react. All right, and that's going to leave us zero reactants if all of it totally reacts. So let's see how many moles of nitrogen gas will produce. So we use the 10 again because it was given. All right, so 7 is less than 8. So I've got to multiply 10 by either the 8/7 ratio or the 7 divided by 8 ratio, okay, to give me the smaller number than 10. And of course it's going to be, we're going to multiply 10 by 7/8. That's going to give me 8.75 moles of nitrogen that's going to be produced. And if we look at water vapor, all right, 8 to 12, so we know that's a bigger number of moles. So I'm going to multiply 10 times 12 over 8 or 8 over 12. If I multiply by 12 over 8, that's going to give me a bigger number. And I do that and I get 15. So I'm going to produce 8.75 moles of nitrogen gas and 15 moles of water vapor. Now, that's cool, and that'll answer anything about this reaction with moles. But what if we're not given moles? Say we're given gram. So on the left-hand side of the equation of the reaction, if we're given grams or liters or particles, we've got to convert it into moles. Always have to be in moles. Always in moles. So how do we do that? On the left-hand side, we always divide. Okay? So if we're given grams, let's say we were given 170 grams of ammonia. Well, if we look at our periodic table and we get the molar mass of NH3, nitrogen is 14 grams per mole, and we have 3 hydrogens and this 1 grams per mole, so that's 17. So if we divide 170 by 17 grams, we get 10. Okay, so that gave me my 10 moles to start with. Let's say they were going to give me 224 liters of ammonia gas. Well, of course, we're going to divide by, because this is a gas, 22.4 liters, and that gives me 10. Okay, so if they give you volume, gas volume, just divide by 22.4. Of course, that is from the periodic table. I'm going to put down PT. All right, so let's say they gave us 6.02 times 10 to the 24th molecules of NH3. Well, then we're going to divide by Avogadro's number, 6.02 times 10 to the 23rd. We'll say molecules. All right, and that's going to give me 10. So that's how we get things into the table. We divide by one of those 3 factors. Now, say they were wanting grams to the right side of the equation. We're going to call this the right side. And the right side, we multiply. That's what the X in parentheses mean. So let's say they wanted to know, and I know this, well, we can do nitrogen. So nitrogen has a molar mass of 28, 14 times 2, 14 for nitrogen, and there's 2 nitrogens. So let's say we've got 8.75 moles of nitrogen. Okay, we've got 8.75 moles of nitrogen, and we want to see how many grams that is, 8.75. So then we're going to multiply by 28. Get my fun calculator here. All right, so 8.75 times 28, that's going to give me 240 grams, 45 grams of nitrogen gas. And if we want to, they ask for liters, then we multiply by the molar volume of 22.4. And that'll give me a volume in liters. That gives me 196 liters of nitrogen gas. And if they ask for particles, of course, that'd be 8.75 times 6.02 times 23rd, 10 to the 23rd. And that'll give me the number of particles. They're really not going to ask that much. I'm not going to ask that much on particles, but be prepared just in case. 6.02 times third. And I get 5.2. I'm going to say 5.3 times 10 to the 24th molecules. Okay, so that's the basics of BCA tables. They're pretty simple, and I think you guys will do very well on the test. Good luck. This is Coach Scott saying, have a great day.